Hello everyone, my name is Joe Pizzini with RenderStream here in Austin, Texas. Today I'll be giving you a demo of our VDACTr8, which is running 8 NVIDIA GTX 580 GPUs. I'll be using V-Ray Realtime, which is a popular GPU accelerated renderer developed by Kpaths Group. In this video, I'll show you some examples of the speed benefits you can expect to see when using an 8 GPU system, as well as the cost savings you could see by rendering your frames significantly faster. To give you a brief overview of the system, we're using dual 6-core Xeon processors, 8 NVIDIA GTX 580 GPUs, 24 GB of main memory, and 2 80 GB Intel solid-state drives. We'll start off with a brief overview of V-Ray RT for CPUs. I'll go ahead and fire up the activeshade viewport, and we can get a good idea of the speed of V-Ray RT on the CPU. Now what you should note here is how long it takes the CPU to converge on a final image. And you can see it takes a while for it to get to what I would call a final image quality. So I'll move the sun around, the light will change, and we get a pretty good idea of how long it takes to converge on a decent quality image. I'll be repeating similar steps later on the GPU, and we can use this as reference. Again, the CPUs being used are dual 6-core Intel X5680 processors running at 3.33 GHz. Okay, so let's go ahead and see how the GPUs stack up. I'll switch it over to OpenCL and fire up the activeshade viewport. Okay, so right off the bat you can see the GPUs are converging on what I call a final quality result fairly quickly. In fact, in this scene they converge on a final quality result in about 2 to 3 seconds. I'll go ahead and do some interactions here, similar to those that I performed on the CPU, to give you an idea of how the two compare. Remember, what we're looking for here is the time it takes for the GPUs to converge on a final quality result from the moment an interaction is initiated. In this particular scene, that convergence is happening in about 2 to 3 seconds. One thing I would like to point out is that the noise produced by the video compression is very similar to the noise produced by the GPUs as they converge on a final image. So what you perceive to be noise in the activeshade viewport could very well just be video compression issues. Okay, so now let's move on and render out an animation sequence using our 8 GPUs. Once again, we'll compare the GPU performance to our dual 6-core Xeon processors. Here we have a side-by-side comparison of our animation sequence with the CPU rendering on top and the GPU rendering on the bottom. What you are seeing is a real-time screen capture of the CPU versus the GPU. Both setups have identical render settings, and both are rendering out a PNG sequence at full HD resolution. If you want, you can skip ahead 2 minutes to go to the next section. Ultimately, the GPU will complete 50 frames in about 2.5 minutes, while the CPU has only completed 2 frames in those 2.5 minutes. Coming up, we'll take a look at how our GPUs handle a much more complex interior scene, and once again, we'll compare GPU accelerated rendering versus traditional CPU rendering. Okay, so here is a rendered image of the interior scene we'll be working with, just to give you an idea of the complexity and the scope. Now, what I want to do is render this on the CPU on basic settings, just to give you an idea of how long this image takes to render. I'm rendering out at 800 by 450 resolution, and what will happen is I'll show you the beginning and the end of the rendering process. That way you don't have to sit through the entire 18 minutes and 20 seconds of this render. Okay, so our CPU-based rendering is about to wrap up. Ultimately, it will finish in 18 minutes and 20 seconds, as I mentioned earlier. Keep that in mind as we move on to the GPU rendering. So now let's go ahead and push this scene out to all 8 of our GPUs for rendering and see how it can handle it. This scene is a bit heavier than our last example, plus it also has additional assets like textures, which need to be transferred to the GPU, so it takes a moment to load up initially. Once the scene and all of its assets have transferred to the GPU, you're ready to begin some interactions and further refine your scene. Let's take a look at some of those examples. So here I'll go in and change the color of the main light to a more reddish color. This will take a moment for the active shader to catch up. Certainly not as long as the CPU would take to do this. In this particular scene, I've noticed that it takes about 16 to 18 seconds to get a decent result in the active shade viewport. Compare that to 18 minutes and 20 seconds for a similar result on the CPU. To put it another way, these 8 GPUs can render a draft animation sequence 68 times faster than a similarly configured CPU render node. The RenderStream VDACTr8 is an extremely cost-effective way to do this kind of rendering. We'll talk more about the cost savings at the end of this clip, but essentially what you have here is an entire render farm in one server. I'll continue to do some more interactions with the lights to give you a better idea of how the GPUs handle a scene like this. If you wish, feel free to skip to the next section on cost savings. Let's take a look at some potential cost savings when using our 8 GPU system. V-Ray RT can be used to produce draft animation sequences for review purposes, as well as produce final animation with certain restrictions. In the previous interior scene, it was noticed that an acceptable result was achieved in about 16 seconds using the GPUs. We also noticed that it took the CPUs 18 minutes and 20 seconds to produce a rendering at medium quality settings. In other words, the GPUs were getting the job done about 68 times faster than the CPUs. To look at this another way, in terms of hardware costs, one would need a very expensive CPU-based render farm to match the computational power of our single 8 GPU server. For example, if a dual 6-core render node costs $3,500, you would need at least 68 of those render nodes, or about $238,000 worth of hardware, to match the computational power of the 8 GPU server. To put that in perspective, the RenderStream VDACTr8 starts at around $15,500. The rendering revolution in terms of GPU-accelerated rendering is really starting to take shape, and the RenderStream VDACTr8 is the ideal solution for this. This system will allow you to rapidly refine your scenes in ways that you've never thought possible before. You can render out draft or final animations at blazing speeds and spend far less time rendering and more time focusing on the quality of your project. Okay, well that about wraps up this demonstration. For more information, please visit us online at RenderStream.com. Also, if you wish to like us on Facebook, you can get regular updates on our various articles and demo videos relating to high-end hardware for the CG industry. That's all for now. Thanks for watching.